Okay, welcome to video 6. Do pause it to have a go yourself first. Right. So this is really a video where I'm going to just write down the various formulae that you need to know. So let's take a second to understand what's going on. You've got a random variable x, okay, which takes some values, and these are usually referred to using little x's. And we don't know how many there are. There are a bunch of them, and we're going to assume that there are gaps between the x values. That is to say, x is discrete. Okay, so it takes values 1, 2, 3, or maybe 2.5, 3.5, 4.5, but it doesn't take any values between certain distinct numbers. And they've got each of these values has a probability related to it. So the notation that's used is you say the probability that x is equal to x1 is called p1. So let's go back to the previous question. Here, in this question, x1, the first value of capital X is 0, and p1, the corresponding probability, is 0.4. x2 is 10, p2 is 0.2, x3 is 15, p3 was k, what we had to find, and x4 is 20, and p4 is 0.1. Okay, so this is just a sort of scary notation for exactly what we were doing in the previous question. Okay, so what is sigma pi? What does that mean? I think that's really the difficulty. It means what do you get when you add together all of the probabilities? So you do p1 plus p2 plus p3 and so on. There isn't a lower and upper limit on this sigma, so the implication is we sum across all possible values of I. So the sum of all possible probabilities, that's just going to be 1. Okay, so that's a fact you need to know. Sigma pi equals 1. Okay, kind of obvious, just written in a slightly unobvious way. A formula for E of x. Okay, let's go back and see how we found the expected value before. What we did was we took the pi values, each pi value, and we multiplied it by its corresponding xi, and we added them together. So that is going to be our formula. E of x equals, I'll write it slowly, x1 times p1 plus x2 times p2 and so on, and then I'll write it using sigma notation, sigma xi pi, summed over all possible values of I. Okay, so that's the formula you need to know. Now, so what's interesting here is this is no longer saying if you did an experiment, what would the expected value roughly be? The expected value is a way of thinking about the average of a random variable and thing which can take different numbers and different probabilities, and it is exactly equal to this formula. So there's nothing approximate about this anymore. Okay? But you can think of it as being what the average would be if you had a completely representative set of outcomes. I'll even write that. Okay? The mean, this is kind of a way of thinking about it, of a representative set of outcomes. Okay, so if you have lots of observations of this random variable x, you spin a roulette wheel lots of times, you roll a die lots of times, and you happen to get a set of outcomes which is completely representative of the probabilities, then their mean will correspond to the expected value of the variable capital X. Finally, the variance. So again, we can go back to our previous thing and look how we calculated the variance. Again, you see the ends cancelling, so we're actually looking at this line. We have here the values the random variable can take squared, so that's a 10 squared, a 15 squared, and so on, times their corresponding probabilities. Okay? Please resist the temptation to square any probabilities. And this thing here is E of x all squared. Okay? So let's just make that into our definition. So this is now a definition. If someone asks you, how do you calculate the variance of a random variable? The answer is you stick it into this formula. x1 squared times p1 plus x2 squared times p2 ... minus E of x squared. And I'll write that using sigma notation as well. That's equal to sigma xi squared pi minus e of x squared. Okay, so in summary you have these three formulae, all of which you need to know. Sigma pi is equal to 1. E of x, the expected value of x, is defined as sigma xi pi, and var of x is defined as sigma xi squared pi minus e of x all squared. Okay? And that's it.